Jai Krishna Guru, everyone. Today in this class we shall do the derivation of compound microscope. In the last class we have got an overview of microscope and telescope, where we have derived the formula for simple microscope, and today we shall derive the expression for compound microscope. The theory part has been explained. So in compound microscope we have seen that two lenses were used. One was the objective lens and the other was the eyepiece. The size of the objective lens was smaller compared to the size of the eyepiece. So here in compound microscope the image will be magnified 2 times. How the image will be magnified 2 times? There is the first lens that will form a real and inverted image behind the lens, and that image will be again magnified by the eyepiece. In this way, the total magnification of the object in compound microscope will be the product of magnification of both the lenses. As I will draw the diagram and do the derivation, things will be clear. Now let us see the diagram of compound microscope. Put this heading. Now do it together with me so that you can save time. This is the objective lens. And this is the eyepiece. When the object is placed here between infinity and center of curvature, the image will form here. This is FO, objective lens. This is small, this is little bit magnified. So imagine this lines are coming this way and the image will form here. In this position the image will form. I have less space, but in your copies you can definitely draw the whole diagram. These lines are coming and intersecting at this point, and this object is further treated. This image, this is the main object to be magnified, and its image is formed here, and this image is acting as a virtual object for this eyepiece, and further it is magnified in this position. So we get a real magnified image for this compound microscope. Okay. Now, tube length. That is the length of the microscope. It is the distance from the second focal point, focal length, and the first focal length of the eyepiece. Second focal length of this objective lens and first focal length of this eyepiece. This will be the tube length L, which we are going to see. Let this angle be beta. If this is beta, this will be also beta. Okay. Now, this is the diagram, but I need some space, so I will drop this part. For clarification on this diagram, you can check the NCERT book of class 12 physics. NCERT book of class 12 physics, that you can check for the clarity in diagram. Now, magnification of this compound microscope is given by the product of the magnification by objective lens and magnification by eye lens. Let us first find this M0. Magnification of objective lens. This is a simple lens, so its magnification is given by h dash by h. This formula we are saying from class 10 onwards. It's very simple. Now, in place of this, can I write L by F0? Yes or no? Now here is no student to respond, so I will respond. Yes, we can write h dash by h is equal to L by F0. This relation is correct because in the diagram, if we see tan beta is equal to h by F0 in one side, and in the other side of the lens, if we see tan beta, then tan beta will be h dash by L. And from here, if we do cross multiplication in this part, we will get L by F0 is equal to h dash by h. So magnification of the objective lens MO is equal to L by F0. This is one equation. You can take it as one equation. Now we will see magnification for eyepiece. Let us see. Eyepiece, the magnification for eyepiece will be similar to the derivation that we have done for simple microscope. Magnification is given by what? H V by U, positive. Now in place of U, I can write V into the mirror formula, that is 1 by V minus 1 by U is equal to 1 by F. Therefore 1 by U is equal to 1 by V minus 1 by F. So here I can write 1 by V minus 1 by F, and if I multiply this, I will get 1 minus 1 by F. But the image distance is in the negative side, that is minus d. So f, since f is equal to minus d, therefore this equation becomes 1 by 1 plus 1 by d me. And for angular magnification, another this is one derivation, and another magnification theta I by theta naught that we have done. Put this as one equation 2, and another magnification for simple microscope. We have found me is equal to fe by d. So this was also another derivation. Now this is our final answer. Now this and this we will put it in this equation in the first formula of magnification. Then we will get it implies m is equal to L by f naught into fe by d. Fe by d. No, it was d by fe. Sorry, it was d by fe. And this formula was also d by fe. Actually, I remember the results, so I could correct it. It was a simple mistake. Because this derivation I have taken from the simple microscope, but here also v by f I have missed one step, so it was mistaken. So now it's correct. So the final answer is m is equal to L by f naught, where L is equal to f naught plus fe, and d is the final image distance. So this is the final magnification formula for compound microscope. I hope this is correct. This is clear to all of you. Now see the book. After seeing my video, see the book once. You will understand it better. Then after that you take the notes. It will be crystal clear. And after that there is one numerical in the exercise based on compound microscope. Try to do that numerically using these formulas. Okay, and if you are able to do the numerical, your concept will be more clear. So with this I conclude today's class, and one more request was there from student side that I must derive the formula for mirror equation, which one I did that derivation in Google Meet. Actually one day I was taking class in Google Meet live class, so the network was disturbing that day, and also many students didn't join that live class, so they are asking it for once again. So although I am not having classes tomorrow and all, I will try to upload that at any time. I will send you the link for that. Okay. So for today's class, now I will have to upload the video also. I will not make it long. So with this I conclude my class for today. Thank you all of you.